If you understand the math behind this, you'll realize it's a pretty sophisticated formula. Fortunately, a number of the financial functions in Excel do all the work for us here. And in this example, we need a function called FV, future value. Another way to phrase this, how much more will I make this way instead of putting it in the cookie jar? Equal FV. In this example, 3%, that may be optimistic depending upon which time of the year it is and which year it is, but let's choose that as an example. And since most kinds of situations like this are likely to be monthly, we want to make sure that that 3% interest is translated into a monthly rate /12. The number of periods here, we're talking about 5 years times 12, 60, comma. And how much are we putting into the account each month? 300. So after 5 years, how much will we have? Now, quick math in your head says 512, that's 60 times 300, $18,000. If we simply held on to it and did nothing with it. And instead we get this much. And if the information is expressed in a negative way, that is technically correct, but I think a lot of people would prefer to have this be displayed as a positive. So, quick change, you're putting a minus in front of the 300 to express the number as a positive number. Now, a variation on this, you see the question row 14, how much money will I have after 5 years based on a $15,000 deposit into an account, earning 3% interest per year? We're not going to do anything with this other than deposit it and watch and see what happens. Equal FV. Left parenthesis, once again we use 3% here. 60 months, just do it directly this time. Now in this case we're not depositing anything, so we don't put anything in there in this example here for a PMT. But we do have a present value of $15,000. Like in the prior example, we want to make this a negative. We are using a different argument in the function here. $15,000. What's that going to be equal to after 5 years? And we see the answer there. Now, you could probably do this mathematically pretty easily, and you could show what it is year by year simply by using caret symbol above number 6 and compounding it that way. A lot of people know how to do that sort of thing, but this certainly gets us the answer pretty quickly, and it does show the different variation on it. Then what I did here in the second example, using a starting value, could be used in the example up above too. For example, what if the money you're putting into this account, you're starting with a $1,000 balance to begin with? So following the minus 300, just before I do that, remind ourselves the answer here we saw previously, $19,394. But what if we start with $1,000, comma, and to be in sync with the other negative, minus 1,000. So that's the money that's already there. And so instead of the 19,000 that we saw earlier, that was 19,394. If we start with $1,000 and then add $300 every month, how much will we have at the end of 5 years? This is the amount. And let's say in the example here, you don't have a choice on the rate. Now, 4% is probably too optimistic for some of these numbers, but still, what if we wanted to build a grid here showing what will happen if we put in $300 and $325? What's going to be the variation here? Now, the numbers here are already in place, but let's show how to create these. And you will make your own judgments as to what kind of variations you want here. If you want to do this every $10, just to show what it might be like here, it's every $25. And this represents the years here. How would we build this? Equal FV. And we'll use this percent right here. And if we're going to be copying this downward and rightward, we will always want to be referring to that cell A5. So by pressing F4, we make this an absolute reference. Divide that by 12. We're talking about monthly payments here, comma. And now the period of the loan is going to come out of A6. And all the others that we'll be using here will come out of column A as well. So by pressing F4 repeatedly, we'll get the $ in front of the A, meaning that part will become absolute. The row number will change. So we want to have to look at $A6, and that represents years. So we need to multiply that by 12, comma. And how much are we inserting for our deposit each time? It's going to be coming out of row 5 here. The first time it's going to be B5. And here too, we want to use a mixed address to make sure that the row portion of this, the 5, remains absolute, but not the column. So pressing F4 repeatedly gives us this look eventually. And here too, we want this to be ultimately expressed as a positive number, so we'll make this entry be negative. So that would be the master formula here. And then we can just double click to copy this downward and then drag across to see what those different combinations of a deposit amount and the number of years adds up to. Powerful stuff, pretty easy to get to with the future value function FV.